This is Module 4, Lesson 26. We're going to start some word problems. So here we're going to solve word problems involving system of equations using elimination and our substitution, okay? Our standard is we're going to solve some real-world and mathematical problems leading to two linear equations and two variables. What we've been doing. Objective here is we're going to find solutions to word problems involving a system of two linear equations. This comes from your Eureka Module Workbook, Lesson 29, and from your packet. Now, first thing I'd like to do, I'd like to go back and solve a system of equations. Let's look at number 7 here. This is the one that's a few pages back. But we're going to do this, and we're going to, well, I'll tell you what, let's do 7. Let's do 7 here. Okay, if I wanted to solve this system of linear equations here, first thing I would do is I would look to see, do I have x is equal to or y is equal to? No, I don't, so I can't use substitution. Here I've got the x's over each other, the y's over each other, the equals are over each other, and the numbers are over each other. So we're going to use elimination. We're going to eliminate one of the variables. If I look at the coefficients, I have 5 and 4 here. I have 2 and an understood 1 here. None of these match. So I'm not going to be able to just directly add and subtract these two equations, and I'm not going to be able to multiply one side of them or one equation by -1. I'm going to have to do something more. If I've got 5 and 4, there's nothing I can multiply 5 by to get 4. There's nothing I can multiply 4 by to get 5. But if I've got 2 and 1, I can multiply this 1 by 2 to get 2. Now keep in mind, I want to get rid of these and I'm adding them. So what I would really do is multiply everything here by -2. If I do that, I'm going to get 2y plus -2y. So that would eliminate the y. So let's use our distributive property. Okay, first let's deal with what we've got. 5x minus 2y is equal to -37. All right, now let's use distributive property. -2 times 4 is -8. And remember, you're always adding these. -8x, -2 times 1 would be -2y. -2 times -29 would be positive, let's see, what would that be? Positive 58, right? Okay. Now, we're adding these two. 5x plus -8x would give me -3x. -2y, I'm sorry, this is positive 2y, right? Plus -2y would give me 0. I've eliminated the y. This is equal to -37 plus 58. You do -37 plus 58. Remember, you can use your calculator to do this. And you get 21, okay? Now I'm solving for x, so I do the opposite of done here. So -3 is multiplied by the x. I divide both sides by -3. And that x becomes -7, okay? So remember, when we're doing this, what we're doing is we're looking for, when we're finding a solution of a system of linear equations, you're looking for where the two lines intersect. The x is -7. Now let's find the y. All I've got to do is plug it into either one of these. It doesn't matter which one, okay? Let's see, how about 4x plus y equals -29? Looks like the easiest one to me. You could use either one, it wouldn't matter. My x is -7, so let's plug that in here. 4 times -7 plus y equals -29. 4 times -7 is -28 plus y equals -29. Now I'm going to need to cross the equal sign. So why don't I add this 28 to both sides? That tells me y is equal to -1. Okay, so there's my answer. -7, -1. That's the answer. Now see, the solution to a series of linear equations is this point where the two lines intersect. Now we're going to see how you do that when you're dealing with word problems. Okay? Now we're going to take this very, very slowly, step by step, because you know when you're dealing with the word problem, there's always reading the equation and writing the two, and reading the word problem and then writing the equation. Here we have got an organizer. This is going to help you to work slowly and to think about what it says. Your organizer. This says what we're going to do is define the two variables from our word problem. See how this is variables? You're going to come up with two variables. What are they? Then they want you to write a system of equations using the given information. When we've talked systems of equations, it's been like x plus y is equal to 8, 2x minus 3y is equal to 10. That's a system of equations. So you're going to be writing a system of linear equations on what we're doing here. This is where you write that system of linear equations. Then you're going to solve the system. That's what we've been doing, is just solving the system. And then you're going to read your question again and say, exactly what did the problem ask us for? When you figure out what the problem's asking you for, that's your solution. Okay? So let's start here. Let's read this and let's see what it's asking us for. First, we're looking for the two variables. The sum of two numbers is 51. So we're talking about the sum of two numbers is 51. The difference of the numbers is 13. Find the numbers. See how we've underlined what's important in our word problem when we're reading it? What does the term sum means? Sum means to add. What does the term difference means? The term difference means to subtract. So we're going to have one equation where we add two numbers and one equation where we subtract two numbers. Variables. That would be our two numbers. What if we call them x and y? X can be one number. Y can be the other number. Okay, because it said we had two numbers, right? There we've defined our variables. That's what they are. Now let's write our system of equations, our two equations. The sum of two numbers is 51. This means we're adding two numbers and they're 51. Here's our two numbers, right? The first number and the second number. X plus y, that's the sum, that means add, equals 51. Okay. The next one says the difference of the numbers is 13. Difference means subtract. So we take one of the numbers and we subtract the other, and the answer is 13. Okay, look, we have written our system of equations. A system of equations, when we're talking about the linear equations, that's two linear equations, right? We're going to solve together. We're going to get rid of one of the variables somehow and solve for the other. Then we can plug it in if we need to find the first. Okay, so they want me to solve this. Let's write it down. X plus y is equal to 51. X minus y is equal to 13. Now we know that we can stop and think, do we have x is equal to or y is equal to? Can we use substitution? No, we don't. The x's are over each other. The y's are over each other. The equals are over each other. The numbers are over each other. We're going to need to use elimination. We're going to need to eliminate one of these variables. If I add these, let's look at our coefficients. We know that our coefficients in front of all these are 1. Okay, so I should be able to get rid of this without having to multiply by anything different than -1, even that. Let's see. 1x plus 1x would be 2x. That doesn't get rid of anything. 1y plus -1y would be 0, right? That would allow us to eliminate the y. So I don't even have to multiply by anything. Let's just solve this. 1x plus 1x is 2x. 1y plus -1y is 0. That y has been eliminated. 51 plus 13 would give us 64. So 2x is equal to 64. How do we solve for x? We divide both sides by 2. X would be 32. Now, what did it ask us for? Remember the last thing it says, the solution. What did it ask us for? Find the numbers. Well, we did. Our X is 32. Oh, we still need to find Y, don't we? Okay. Choose either one of the equations. You could say X minus Y equals 13. Substitute, that'd be 32 minus Y is equal to 13. Let's subtract 32 from each side. Negative Y then would be equal to 13 plus negative 32. That would give us negative 19. Let's divide both sides, because you know there's an understood one there, by negative 1, and Y is equal to 19. X is 32, Y is 19. And guys, we always know what we're looking for is where the two lines intersect. Our solution is what? 32, 19, okay? Let's try another one. Now, this is an organizer for our things. They're not going to always give you the organizer, because you can use the organizer if you want to. You can write the organizer down. It won't be available there whenever they write one of these problems for you on Leap or even on my test. But you can set this up if you want to. Braden bought 3 adult tickets, 3 adult tickets, and 1 child ticket at the movie theaters, and he paid $32. Notice how we're underlining the words that are important in here. Karen bought 7 adult tickets and 2 child tickets and paid $73. What is the cost for 1 child ticket? So see, the solution is going to be the cost for 1 child ticket. See, I'm making myself notes as to what it's telling me here. Okay. We need some variables. Now, you don't have to always use X and Y, and usually when you're dealing with the word problem, you will use a letter that makes sense here. If we're talking about 3 adult tickets, okay, he bought 3 adult tickets and 1 child ticket and paid $32. Okay, we're going to looking for the amount of money that a child ticket costs. So what if we say A is equal to the cost of adult ticket? Okay, because that's what we're adding everything up to, is what it cost, right? And C was equal to the cost of a child's ticket. Okay, there's my 2 variables, A and C. And I said it was the cost of the tickets, not the numbers, because the things I'm adding this up to is cost here, right? Let's write a system of equations. If Braden bought 3 adult tickets, 3 times the cost of an adult ticket, plus 1 times the cost of a child ticket, and it cost him $32. Doesn't that make sense? 3 times the cost of an adult ticket plus 1 times the cost of a child's ticket is $32. Let's look up for the other equation. Karen bought 7 adult tickets, okay? So 7 adult tickets and 2 child's tickets plus 2 child's tickets would cost us $73. Okay, there's your 2 equations. See? Neither one of them says A is equal to or C is equal to, so I can't use substitution. I'm going to have to use elimination. To solve it, let's put the 2 of them on top of each other. 3A plus 1C is equal to 32. Let's make sure the variables are on top of each other. And 7A plus 2C is equal to $73. Okay. And you got to make sure all these things multiply up. 3 times the cost of an adult ticket would give you the money for the adult tickets. 1 times the cost of a child ticket would give you the cost, would be of what you spent on a child's ticket, and you're adding them together to figure out the total cost, right? Okay. Now, we need to get rid of a variable. We need to eliminate one. We can't eliminate 3 or 7 because I can't multiply either one of these by something to get the other. Can't multiply 3 by anything to get 7. Can't multiply 7 by anything to get 3, can I? Can I multiply 1 by something to get 2? Oh yeah, I could multiply it by 2, couldn't I? Now let's think, do I need a positive 2 or a negative 2? Down here I have a positive 2. If I'm adding these, then I'm going to need this to be a negative 2, right? Now let's use the distributive property. Negative 2 times 3a is negative 6a. Negative 2 times 1c is negative 2c. Negative 2 times 32 is negative 64. Okay, and let's write down what we've got here. 7a plus 2c equals 73. Negative 6a plus 7a gives me 1a. Negative 2c plus 2c gives me 0. I have eliminated the c, the cost of the children's tickets. This gives me negative 64 plus 73 would give me 9, okay? So an adult ticket costs $9. Is that what they asked me for? See, the solution says, what's our solution? Find the cost for one child ticket. No, we want the child ticket. I've got the adult ticket. How do I find the cost of the child ticket? Well, wouldn't we plug it into one of our equations? Either one, doesn't matter which one, right? 3a plus 1c equals 32. So we've got the adult, now we're looking for the child. All right, our a is 9. 3 times 9 plus 1 times c equals 32. 9 times 3 is 27, plus 1c is equal to 32. I'm trying to solve for c. I'm going to need to subtract 27 from both sides so I can move it over the equal sign. When I'm moving over the equal sign, I do the opposite of what's there. 1c then is equal to 32 minus 27. Put that into your calculator. 32 minus 27 would give you 5. Your child's ticket would cost $5. Now, think about this logically. You said your adult ticket was $9. Would it make sense for your child's ticket to be cheaper? Yes, it would. Okay? Let's look at number 3. And we're going to use our graphic organizer to help us read the problem. At the fast food restaurant, one hamburger and 5 fries cost $8.74. 2 hamburgers and 3 fries cost $7.75. What is the cost of one hamburger? So our solution is going to be the cost of a hamburger, right? Making myself notes there by solution as I read, okay? The graphic organizers to help us understand the problem. We need to decide on some variables. And when I talk about variables, the first thing I look at is, what are they asking me for? Oh, the cost of a hamburger. So one of the variables is going to have to be the cost of a hamburger, right? That's what I'm looking for. Cost of a hamburger. What do you want to call that hamburger? Okay. How about if we give it the variable h, because that way we can see what it is. We want our variables to be something that makes sense. I'm going to call h the cost of a hamburger. So what else do we have? We have fries. So how about we say f is the cost of fries? See, our variables has always got to contain one of the things it's going to contain is whatever we're looking for. Now let's write our system of equation. 1 hamburger, 5 fries is $8.74, right? So 1 hamburger plus 5 fries equals $8.74. What's the other one? 2 hamburgers, 3 fries is $7.75. 2 hamburgers, 3 fries, $7.75. Okay? Now, when we're trying to decide how to solve it, we ask ourselves, for either one of those variables, does it say h is equal to or f is equal to? And it doesn't, so we're going to need to use elimination. 1h plus 5f equals 8.74. And remember, when you're doing elimination, you're adding the two equations. 2h, h's are on top of each other, f's are on top of each other, equals are on top of each other. Then we got 775, right? I've got to eliminate one of these variables. Let's look at our coefficients. 5 and 3. I can't multiply by 5 by anything and get 3, or 3 by anything and get 5 without it being a fraction. Can I multiply 1 by anything to get 2? Multiply it by 2, couldn't I? Now I'm trying to get rid of one of the variables, so I need my coefficients to be opposites. If this is a positive 2, I need this to be a negative 2, don't I? Let's multiply negative 2 times everything up here. That would be negative 2h, see, we're using our distributive property, minus 10f, and let's multiply 874 times negative 2. 8.74 times negative 2 would give you negative 1748 equals negative 17.48. I'm going to put that over there so we don't see it, okay? Now, let's add our bottom line. 2h plus 3f equals 775. Negative 2h plus 2h gives me 0. I've eliminated h. Negative 10f plus 3f gives me negative 7f. Negative 1748 plus 775. Put that in your calculator. And that gives you a negative 973. Okay, let's divide both sides by negative 7. And the cost of fries is $1.39. Now, is that what they asked me for, was the cost of fries? Nope, asked me for the cost of a hamburger, didn't they? So I'm going to need to plug it into one of these equations. I'm going to try this one. 1h plus 5 times the fries, and the fries is $1.39, isn't it? See? Equals $8.74. Okay, let's see. How much do we pay for our fries? 5 times $1.39. $6.95. So the cost of the hamburgers plus $6.95 equals $8.74. All I got to do is subtract the cost of all the fries from the total cost, and that should give me the cost of a hamburger, one hamburger, right? One hamburger then would cost $8.74 minus $6.95, which is $1.79. So one hamburger costs $1.79. What did they ask me for? The cost of a hamburger, which is $1.79. Although I was able to get where these two lines intersect, which would be 1.39 and 1.79, all they asked me for was one of the answers, which is the cost of a hamburger. See, when you're doing this, these equations actually represent real-world scenarios, okay? And where these two intersect, in this case, if we've got H and F, hamburgers and fries, let's see, 1.79 and 1.39. Okay, they're still points on a line where we were dealing with something like this. 1.79 is your cost of your hamburgers. That's on your x-axis. Cost hamburgers. This would be cost of fries, okay? All right, guys? So it's pretty simple, and that lets you figure it all out there. These are actually real world scenarios. This is how it's used in the real world. Okay? Let's look at another batch. Number 4. Colton sold a total of 28 t-shirts, total of 28 t-shirts and sweatshirts, okay? As part of a fundraiser for his football team. T-shirts cost $12 each. Sweatshirts cost $20 each. He raised a total of $424. How many t-shirts did he sell? Number of t-shirts is what we want to know, right? That's what we're looking for. Okay, now we're going to start seeing some things where we're going to use some equations that have different things they add up to. So let's look at this. Colton sold a total of 28 t-shirts and sweatshirts. So we're talking about the number of t-shirts and sweatshirts sold, right? What if for the variables? I'll say T is equal to, and see, we're looking for number of t-shirts. This is the number of t-shirts sold, right? How about if I use S for the number of sweatshirts? That's two good things from our variables, right? Now let's write our two systems. We need two equations, don't we? Carlton sold a total of 28 t-shirts and sweatshirts. Okay, couldn't I say the number of t-shirts plus the number of sweatshirts is equal to 28? That's the total number he sold, right? Okay. Then it says if t-shirts cost $12 each and sweatshirts cost $20 each, he raised $424. So the total amount he has is $424. That's money, right? T-shirts are $12 each. Can I multiply the number of t-shirts sold by 12 to figure out what you made on t-shirts? Plus, sweatshirts cost $20 each. 20 times the number of sweatshirts sold, that's your S, it's not a 5, would give you how much he made on sweatshirts, right? And he made a total of $424. Now I realize this is money and this is number of shirts, but see how we still have our variables lined on top of each other. T's are on top of each other, S's are on top of each other. We have a system of linear equations. We know we're going to need elimination because nothing says T is equal to and nothing says S is equal to here, does it? So let's solve our equations. T plus S equals 28. 12T plus 20S equals 424. Okay, I need to get rid of one of these variables. I need to eliminate a variable. I would ask myself this, what are they looking for? They're looking for the number of t-shirts. See, there's a 1 in front of each of these, so one time I can multiply this one times 12, and we could get rid of the t. I could multiply this one by -20, we could get rid of the S, but I'm looking for the number of t-shirts, so why don't we keep it and get rid of the S? To do that, I need both of these to be 20, one to be -20, one to be +20. So why don't I multiply everything here by -20? If I do that, I've got -20t, and -20 times S would be -20S would be equal to, what's -20 times 28? -560, right? Then let's just bring this equation down here. 12t plus 20s equals 424. Whenever you're eliminating a variable, you're always adding the two equations. Negative 20t plus 12t would give you negative 8t. Negative 20s plus 20s gives you 0, so you've eliminated the s. Negative 560 plus 424. Well, let's do that. 560 and 424, and I would have negative 136. Let's divide both sides by negative 8, and t would be 17. This tells me I would have 17 was t, number of t-shirts. And then what I'm looking for is how many t-shirts did he sell? He sold 17 t-shirts, right? Okay. I always look back to say, what did they ask me for? Number 5. Caitlin has two part-time jobs. Tutoring and working at the grocery store, right? Okay, I'm going to call tutoring grocery store. Last week, she worked a total of 15 hours. If she makes $15 per hour tutoring, $9 per hour at the grocery store, and made a total of $159, how many hours did she work at the grocery store? So we want to know number of hours at grocery store, right? Make this so we can read a little better. Number of hours at the grocery store. Okay, say number of hours grocery. Okay, so we need two variables, don't we? Well, we're looking for the number of hours at the grocery store. So how about we say G is equal to the number of hours at grocery. Okay. What's our other thing? What's our other hours thing we're talking about? Tutoring. Okay, so let's say T. T is to equal to the number of hours tutoring. See how I used what it told me here? The number of hours, that's what we're looking for, right? We need the same units here. Number of hours at the grocery, that's what it said. Number of hours tutoring, okay? We need to write us some equations. So we need two equations. Okay, she works at tutoring and the grocery store. Last week, she worked a total of 15 hours. So would the number of hours at the grocery store plus the number of hours tutoring give her 15 hours? Okay, that's one equation. Now let's write the other. She makes $15 per hour tutoring. Okay, so 15 times the number of hours tutoring plus $9 per hour at the grocery store, 9 times the number of hours at the grocery store would give her $159, right? Okay, so we're looking for the number of hours she worked at the grocery. Neither one of these say G is equal to or T is equal to, so I'm going to need to use elimination. G plus T equals 15. I have lined up my G's here. 9G, see I'm lining up my G's here. Plus 15T equals 159. Okay. I need to get rid of one of these variables. I need to eliminate one. What are they asking me for? For the number of hours at the grocery store. So why don't we get rid of the tutoring? If I can get rid of it, then I don't have to plug it back in. It's a quick thing. Well, I know that there's an understood one in front of each of these. If I'm trying to get rid of the tutoring, don't I need this to say negative 15? So if I've got one there, I need to multiply everything here by negative 15, don't I? Let's do that. Negative 15 times 1 is negative 15G. That's minus 15T equal, what is negative 15 times 15? Give me negative 225. Remember, I'm always adding these things. 9g plus 15t equals 159. Negative 15g plus 9g would give me negative 6g. Negative 15t plus 15t gives you 0. You've eliminated this one. 225 plus negative 225 plus 159 gives me negative 66. Let's divide both sides by negative 6. And G is equal to 11. G, which is the number of hours at the grocery store, that means she spent 11 hours working at the grocery store. Okay, number 6. Rick bought a total of 8 pounds of steak and chicken. So total of 8 pounds, and it's steak and chicken. Steak costs $13.50 per pound. Chicken costs $3.25 per pound. He paid a total of $77.25. How many pounds of steak did he purchase? Now to decide on our two variables. We're talking about steak and chicken. Okay, now what did it finally ask us for? How many pounds of steak did he purchase? So this is going to be pounds of steak. Okay, so we're talking about steak and chicken. So here are my variables. I'm going to say S is my pounds of steak. And I'm going to say C is my pounds of chicken. See, I've used S and C, and it tells me what they are. I can tell what they are when I'm doing it. Now let's write our system of equations. He bought a total of 8 pounds of steak and chicken. So if we add together the amount of steak, number of pounds of steak, plus the number of pounds of chicken, I've got a total of 8 pounds. The steak costs $13.50 per pound, so $13.50 per pound times the steak, times the number of pounds of steak, plus the chicken is $3.25 a pound. $3.25 times the number of pounds of chicken would give me the total amount he paid, which is $77.25. Okay, I've got two equations now. Both of them use S and C. Now let's solve these. Let's set them up. Number of pounds of steak plus the number of pounds of chicken is equal to a total of 8 pounds. So I spread it out so I could put these other numbers in there. $13.50 per pound times the number of pounds of steak plus $3.25 per pound times the number of pounds of chicken will give me the total cost, $77.25. See, these are different things here. As long as you got your C's over each other and your S's over each other, we're in good shape. Now, I don't have anything that says C is equal to or anything that says S is equal to, so I can't use substitution. I'm going to have to use elimination. I'm going to have to eliminate one of these variables, either the S for the number of pounds of steak or the C's for the number of pounds of chicken. What am I asking for? I'm asking for the steak, so let's get rid of the chicken so I don't have to, solve for S and then plug in to solve for C and then plug in and solve for S. Let's just get rid of C to start with. Well, let's see. I know there's an understood 1 here. To get rid of this C, this needs to be negative 3.25, doesn't it? So if I multiply this 1 by negative 3.25, in other words, let's multiply everything here by negative 3.25. Let's make sure we can see that a little bit better. Multiply everything here by negative 3.25. Okay. Our equation will be negative 3.25 times S plus negative, see, plus negative 3.25c, or you can say minus 3.25c, equals, and negative 3.25 times 8. Let's look and see what you got there. 3.25, use your calculator. That would be negative 26, okay? Now, remember we're adding this to it. We've got 1350s plus 3.25c equals 77.25. Okay, now 1350 minus 3.25, or negative 3.25 plus 1350 gives me 10.25. So we got 10.25s. And this negative 3.25c plus 3.25c gives you 0, so that is eliminated. You've eliminated the c. Negative 26 plus positive 77.25. Okay, that's 51.25. And I need to divide both sides by 10.25. And that should give me the pounds of steak. Let's see. 51.25 divided by 10.25. Oops. And that would get me 5. S is equal to 5. Now, what was S? S was the number of pounds of steak, which is what they asked me for. How many pounds of steak? 5 pounds. Okay? And then let's do the last one on this page, and the rest of them here we will save for another video. Anna has a collection of 49 nickels and quarters. So we got 45 nickels and quarters worth 805. How many nickels does she have? This is the number of nickels. Always put your solution down here, what we're looking for. Now variables. We're talking about N is our number of nickels. So this is what we're talking about. Q would be our number of quarters. We need 2 equations here. There's 45 total nickels and quarters. So the number of nickels plus the number of quarters equals 45. The total value of it is $8.05. Well, we know the nickel is worth 5 cents. That's 0.05 times the number of nickels gives you your value in nickels. Quarters are worth 25 cents. 0.25 times the number of quarters would give you your value in 25 and quarters, right? So let's solve the two. We've got N plus Q, that's the number of nickels plus number of quarters, is equal to 45. 0.05, that's what a nickel's worth, 5 cents, times the number of nickels gives you your value in nickels. 0.25 times the number of quarters gives you your value in quarters. And that gives you 8.05. Okay, now I'm looking for number of nickels. So let's eliminate the quarters. If this is positive 1Q and this is positive 0.025Q, I need this to be negative 0.25. So multiply everything here by negative 0.25, okay? That would give me negative 0.25 N minus 0.25Q would be equal to negative 0.25 times 45. That's a negative 11.25. Okay, and then we've got, you're adding this, remember, 0.05N plus 0.25Q equals 8.05. Now, since we're adding everything, these two, negative 0.25 plus 0.05, that would give me negative 0.2 n. These two cancel, that gives me 0, so it's gone. Negative 11.25 plus 805. And that would give me negative 3.2. Okay, so let's divide both sides by negative 0.2. And n is equal to 16. The number of nickels would be 16. Okay? N stands for number of nickels. All right. That's where we're going to stop at this particular time. We will have a part 2 of this later.